Hello everyone, and welcome to session number 7 of the Printed Circuit Board Design Principle and Practices. In our today's session, we will cover every single aspect of libraries and component creation from scratch in Altium Designer. We will have more in-depth look into the Schematic Symbol Editor as well as the PCB Footprint Editor, and also will discover the tools available in the schematic and PCB footprint editors for creating component from scratch. The physical component that is mounted on the completed printed circuit board is represented in Altium Designer in a variety of ways. On the schematic, for instance, as we can see in here, the component is represented by a physical or logical symbol. On the PCB design, it's represented by its footprint. And the footprint could be associated with a 3D model. Similarly, the schematic symbol can be associated with simulation model. Each of these representations is referred to as a domain model, and Altium Designer uses this term domain model to refer into different representation of the component in Altium Designer. The schematic symbol typically includes a shape which can reflect the function of that component and include one or more pins. As we can see in this symbol in here, we have 4 pins representing the function of a switch that connect pin 1 or 2 into pin 3 or 4. In some cases, one schematic symbol can represent the entire physical component. In other situations, the component can be defined by multiple subparts, where each subpart represents a logical entity within the physical component. For example, we see here the operational amplifier, which has quad stages. It's LM324. It has 4 op amps within a single chip. Now, these are called subcomponents belong to one component. And we will practice today how we can create a component with subcomponents similar to this. Also, we will see how we can create a component with multiple modes, like if you have a resistor in US style or in Europe style. So how we can create a component that include both styles, and you can select which style to go with during the placement. Now, the schematic symbol editor can be accessed if you create a new library, as we see in here, and we will do that in more details. So when you start a new library and add the schematic library to it, which has a format SCH-lib here, as we can see. So on the left side here, you have the schematic library panel that shows or lists all the components within that library. And also in this library, you can add a new library or a new component, delete this component, or edit the component, or replace the selected component into a schematic sheet. So it will place it into whatever available schematic sheet or open schematic sheet in here. It will place the component to it right away. Here you can add the supplier information or supply chain information or supplier link in here. On the bottom panel, you can add or link a component, or as known by Altium Designer, domain models like footprint, simulation model, signal integrity model, etc. You can have multiple footprints or multiple simulation models in here. So in here, you have the document for where you can create a symbol or edit a symbol in this area. And this cross in here, it's the origin of the document. If you want to create a symbol in here, it's always recommend that to align the symbol into this origin in here. Don't go far away from this origin. On the top, you will have some toolbars you can show or hide. We will take a look at these as well. And of course, if you can access the schematic library in here from the panels command on the bottom right side in here. So let's take a look at the schematic editor before we move to the next slide. Okay. So this is our library that we created in session number 6. We copied couple components or reused couple components. We did not create anything from scratch. Basically, we opened different libraries for different vendors, and we learned how we can copy a schematic symbol or PCB footprint or both, and how we can link them together. So let's take a look at the schematic editor first. So this is one of the components. So in the panel here, you can see the schematic library. If you click on it, the schematic library will come up in here. So in here, we have 4 symbols, 4 schematic symbols, and for each one we have a unique design item ID. There is no way you can have 2 symbols within the same library with the same item ID. Every single component should have a unique item ID. If you try to create one with the same item ID, you will get an error, and Altium Designer will not allow you to do that. So when you click on place, basically you are placing a component into a schematic sheet. So if you don't have one, Altium Designer will start a new one, as you can see in here, and now you can place the symbol into the schematic sheet. So if you go back to the library, schematic library, this is for place add. Basically you are adding a new component, and we will do that when we create a component from scratch. And let's do it. So if you create a component, you added a component right now here. So the default name for this is that. If you need to edit that, double click on it. The properties panel will come up in here, and you can change the design item ID. The best practices, and I always recommend that, use design item ID, use the part number. If you search for a component, specific component, just use the exact part number for that component as design item ID. So this will make it easier when you search for the part or try to look up the part. So let's go back to the schematic editor. So delete, you can delete any component in the list by click on delete. It's gone. If you want to edit any of these, you can click on edit in here, and this will come up. So now you can have the properties, and you have the component as well. You can edit the symbol, or you can edit the properties in here. So you need to click on the component to get the properties for that component, and also you can see the footprint in 2D and 3D. You can see the supplier link, description. You can see that design item ID. This number is basically the part number of this component. If you go to DigiKey or any part supplier and search for this part number, this component will come up in the search results. Let's take a look at that very quickly, just to practice this. So here, let's go to DigiKey for instance, and let's search for this component. Here we go. So it's a transformer for LAN networks. It's 10 over 100 megabit per second, and it's surface mount. So the available quantity for this component is that you have 1,774. The cost per piece is $3.52, and you get more information about this component in here. Of course, if you buy in large quantities, the price will drop. So this is just one example. And here you can see the parameters, and also you can see the bins. If you recall the session number 6, you have here the bins, and on the bins, if you click on the edit in here, you can go to the bin or component bin editors. You can see the bins in here. The name of these bins, you can change that name, and it's editable. And this is the order. This is the designator. And this is the order of these bins. This is the type of the bin. You can change the type of the bin based on the functionality of that bin, and we will see that when we create a new component. So you need to say if this component is input or output or high impedance or open collector or power or whatever, and this will help the electrical rule check to check your design and make sure there is nothing wrong with it. So this will show or hide. You can show or hide this component. So you can show or hide this component on the schematic sheet, and also you can show the number. And let's expand this a little bit. If you want to show the name or hide the name, you can hide the name or show the name. You will see in some cases when you create a microcontroller, you want to show the name and show the number as well. So here you can see general information when you select a bin. This is a dynamic, will change. This will show the position on the schematic sheet in X and Y and the rotation for that. The designator, each bin should have a unique designator, and also the name of that bin and the electrical type. Basically anything you see in here, it's here in for one bin. We will talk about the symbol that shows next to the bin or inside the bin based on the functionality of the bin. So if you have open collector, or you have, for instance, high impedance or pulse or clock signal, there is a symbol. This doesn't change the functionality of the bin itself, but it's for representation purpose. That's it. So once you are done editing, you can close this one. If you want to add a new bin, you can add it in here. So we have a bin in here, and also at the same time you can remove any bin you want. So this is just a quick review on the bin editor. This is just font editing and font setting. You can change the size of the font, and this is generic things. We don't want to go into it. It's similar to the Word or any text editing software. You just change the color or the size or the orientation as well. So this is how you edit the bin. At the same time, if you don't want to come into the properties, let me duck this one. Okay, if you don't want to come to the property and edit the bin from here, if you go to the general, double click on the bin, and the properties will come up in here. It's similarly exactly as you go into, if you click on the component, go to the bin and edit. So if you click on the double click on any of these bins, you can see the properties of that bin, and you can change that. And these properties, as I said, it's designator number. You see it's 16. You see it's 16. The name of it in here. So the designator, basically when you create a footprint and you try to link the footprint into the schematic symbol, so the paths on the footprint will be linked to the schematic symbol or the bins on the schematic symbol based on the designator. So 16 should go with 16, 1 should go with 1. So it's very important to know the exact bin number of the chip. So you need to open the data sheet and look into these details. So no worries for now. We'll do that today in details. Now on the bottom side, as we mentioned here, you can link the other domain models like footprint, simulation model, etc. So all that you need to do is to add, for instance, a footprint. The PCB model will come up, and now you can browse. You can select the library. If you have multiple libraries, you can select them in here, and then select the associated footprint for this model. When you click on it, or you can search for it. Okay, if you click on it, now if you click on pin map, you can see how these bins are mapped based on the designator in here, and also the bad number in the PCB footprint layout, as we will see. So here bin number 1 will be mapped into bin number 1, bin number 11 will be mapped to number 11, and so on. So you can see all that just to make sure about it. So okay, so we have now 2 footprints, and they are identical, and these belong to the same component, and we don't need that. So what you can do, you can edit that to select a different footprint, or you can remove it as well and keep the original footprint you have in here. Now in the same time, you can add simulation module. If you click on simulation module, should come up in here. Yep, this is the simulation module editor, where you can add a simulation module. Now there are predefined models you can use for passive component, mostly for passive component, and in the same time you can create a new model and import that into here as well. Here you can see these functionalities for this component, and you can select what kind of model you are looking for. Is it general model or initial condition, transmission line, voltage source, current source? If it's general, now you can go and browse in here and try to find the model. As you can see, this is the default library in Altium Designer, where you can find a model for diodes, transistor, capacitors, inductors, resistors, and other components you can use off the shelf, and you can modify these models as well. So if you don't if it's not of the between this list, you need to create a model. So if you select, for instance, this diode will come up in here, and you will see the parameters and information about this model in here in the model file. So if it's not one of these models, you can basically copy and paste the simulation model or SPICE model into here to simulate this component, and it will be added into here. So if you added this simulation model, but this is not the right one, so let's remove it. Let's go to the model manager. This is something also where you can edit all the schematic symbols. And if there is something in here, instead of looking into one symbol basically and select a symbol, here you have model manager. So you can see all the schematic symbol and you can edit each one of them within one panel. So here, or you can edit also all of them. So you can see all of them. You can add something common for all of them or remove all of them. So let's remove this, for instance. Okay. So it will be removed in here and will be updated in here. As you can see, it's just model manager. So you can access the simulation model, the model manager, either by right click in here and you will see the model manager in here, or you can go to the tools, model manager in here, and you can see edit the component you want. And this is very handy. As I said, if you have a resistor, 100 resistors, all of them have the same footprint like 0603, and you can basically select all of them and add the footprint to all of them, and it's just one command. You can update multiple components at the same time. Now, how you can edit the footprint editor here in preferences. If you go back to the slide, let's go back to the slides. So editor workspace dialog. So how we can access the properties of the schematic symbol editor. So basically, if you click on the free space in here and go to the general, you are not see where can I change, for instance, the grid size, the font, or any other information. It's not in here. These are basically the properties. Even if I'm clicking on the free space, these are the properties of the component being selected. How we can access the editor properties? So all that you need to do is you go tools, document option. Remember, we are editing a document, and this document belongs to a schematic symbol. So click on document option, and now the properties will change to reflect the properties of the document itself, where you can select the units, millimeter or mils. Also, you can show the visible grid or the snap grid in addition to the color as well. And if there are any hidden bin, as you can see in here, you can show the ease, and also you can show the designator and the comment. And by the way, the designator and comment will show automatically once you place the component in the schematic sheet. So no worries about that. But if you want to show them as well in the component editor, you can do that from here. And of course, you can move it and align it in the place you want. You can do that definitely. So if you want to go back to that, you can go document option, and you show the grid and snap grid. Now, make sure to have a snap grid that is 100 mil. So the positioning for 100 mil for this pin. So if I move this pin, as you can see in here, so it's 100 mil. As you can see, this is 100 mil. There is no way you can move it 50 mil or closer to that. It makes no sense on the schematic symbol. And this is just graphical representation of the electrical function of the component, and it will help you to do the electrical connectivity. So it's not the pitch of the footprint. So always work on 100 mil grid unless you really have to use a smaller grid for creating a symbol. We are talking about the symbol editor. So 100 mil is very good and very efficient, and you can move these pins very easily. So if we go back to the document option, so 100 mil is fine. Let me show you what 50 mil. This is a visible grid. So this is a fine grid, as you can see in here. Document option. So this is 50 if we want to move the component. Now we can move the component even, as you can see, it's much closer. Now they are very close. This is 50 mil spacing or 50 mil snap or grid. So, but I cannot fit the text unless I make the designator or the text for this bin is very small. And this makes no sense, of course, at all. Now, what is the other problem with placing the component on a grid that is not symmetric or very fine grid, like 50 mil or 25 mil? The problem is when you go to the schematic sheet in here, if your grid in here, it's, let's say it's 100 mil, you won't be able to snap for the bin between these two bins that is at 50 mil unless you change your visible snap grid into 50 mil. So as you can see here, it's 100 mil. So if I'm trying to connect anything, it's between here and here. Now the spacing between this one and this one is 200 mil because we have two blocks, as you can see in here. So, but if you want to try to connect with a bin that is placed in here, there is no way I do that until I change the visible grid and snap grid into 50 mil. So this is a problem with it. And also the maximum you do usually for visible grid or snap grid as a standard is 100 mil, and you go smaller, you don't go larger. It makes no sense to go larger. So that's why I recommend to place the component on a grid that is 100 mil. Don't go smaller when you do schematic symbol component creation. 100 mil is good in here. So this is very important point, and just keep it in mind. Also, there is another point we need to focus on in the layout for the PCB footprint components. Now, where else can I access the editor properties as well? Remember, there are toolbars in here you can show. Altium Designer by default hides all these toolbars because you have shortcuts, you have the dynamic properties panel. Whenever you click on something, only the associated command will be present for you to use. But you still can show the legacy. I'm not sure if I can call these legacy toolbars, but these were essential, and they were in the default view if you call Altium 17 and older version of Altium. So a Schematic Library standard toolbar in here, and also utilities toolbar where you can control and change the grid. We'll see that. And the mode, this is important if you have a component with multi-mode. This is when I talked about a resistor with two different modes. The first mode shows the US symbol. The second mode shows the Europe symbol, the difference between the two. So here you can add or delete a mode or switch between the modes. Here you have the navigation. It will come in here where you navigate and search, etc. So let's take a look in here. So if you look at this one, this you can show the snap grid, set snap grid. This is the snap grid, similar to what you saw on the document tools, document options. This is the snap grid. So you can basically set the snap grid from here. And also you can cycle the snap grid. What does that mean? That means you have predefined settings, multiple predefined settings for the snap grid. By clicking on the G, you can cycle between these. So how we can define these? It's very easy. You go to the preferences. The schematic editor for the symbol has the same settings or same default settings as the schematic sheet editor as well. So you need to go into the schematic. Now you go to grids, and here you can see the predefined settings for the grid in imperial as well as in the metric. So here you have 25 mil, 50 mil, 100 mil. So you are telling Altium Designer, also we can add, defaults. This is the defaults. If you do Altium presets, this is the default because I changed these basically. So you can add grid settings to it. So I need the 25 mil to be added to it, and I need to move it up. So I have them in order, because when you click on the G key on the keyboard, they will cycle based on the order you have here on the list. So basically when I added 25 mil, I'm telling Altium I need to snap into a grid that is 25. The snap distance is 25 as well. Do you recall when we mentioned that your snap distance should be equal to the snap grid, or can be smaller? It cannot be larger, your snap grid. Always the snap distance can be equal or smaller than the snap grid, and my recommendation is to have it always equal to it. So visible grid, as we saw in here, it's also equal to the snap grid, and I like it like that. So all the time I do visible grid equal to the snap grid, so I can know that the snap grid is changing in here. So these are the settings. Now let's take a look. Okay, so if you can see the grid in here, now it's 100. And we can see that if you go to Tools, Document Option, and let's Tools, Document Options, let's have this in here. Oh, it will not stay. So if I click on G, now it's 10. It's very fine, as you can see. Another click, it's 25 now. Another click, it's 50. Another click, it's 100. Now, looks like at 50, it uses visible grid 50. Okay. So it will cycle through these by clicking on the G. So this is also handy command in here. You can access it very quickly. So cycle snap grid reverse, basically you go from bottom up. You go from, if you are in here, so when you cycle in reverse, you switch from 15 to 25 mil. It's backward. And here you can basically set a snap grid that is not in the default or in the preferences. You can set, for instance, snap grid. I need snap grid is 200. But now we will have a problem if you try to move this component. Look, if you you cannot select this component because it's, you see, I can only switch two blocks. Each one is 100 because the visible grid is 100. I'm just can snap into 200. So we can do it back. If I click on G10, and this is 100 now. Okay. Yep. This looks 10. Okay. Now let's go back to the slides. So in the schematic symbol, you can change the default unit in the preferences as well. So if we go back to the editor, you go to the preferences, you have defaults, and under the defaults, these are the default measurements. You can either go with mils or millimeter. Once you go with millimeter, you will see this will change in here right away. So these are the default measurements. You can go with either one. Once you click on this or you select the default, it will be used all the time in here. Of course, you can change it. One of the way to change it, you can click on Q, and Q will change between millimeter and mil as well. It's shortcut. So now more settings. We talked about the grid. Now objects are placed on the current snap grid. The current grid is displayed on the hand left end of the status bar. Now this is a nice idea. Now whatever grid you select by cycling these or in the editor in here, you can see it in here. So the grid here on the bottom left side, you can see now you are using grid 10 mil. Now let's click on the G key on the keyboard. Now it's a 25 mil, 50 mil, 100 mil. So you know what is the grid right now you are using right now. So by looking into the status bar at the bottom. Also on the status bar, you can see the coordinate of the cursor right now. So if you click on this bin or this text, you know that the coordinate for this text is located on 150 mil and 100 mil. And if you go to the properties for this, this is where the handler of this text exists. It's 100 mil and 200 mil. And if you change this, you can move the text. So let's get it back to the default. So by pressing the key, you can cycle the snap grid through the available settings in here. You can always edit these settings, add more settings to it, and change the order as we saw. Now, available settings can be edited in schematic grid page of the preferences dialog, as we did just now. So I put this information also on the slide as a reference for you when you go back to the video or the slides, so you can review and practice these things we have done in our session today. Now, typically objects and bins are placed on a grid of 100 or 50. This is a typo. So go with 100 or 50. Don't go with 10. With the strings being the only object needing to be placed on a grid of 1. So the comment in here says if you have a string like that, this is not aligned to a bin. Now basically you don't have to put it on a grid or snap it to a grid. No, this has nothing to do with snapping it to a grid. Basically you can select your grid to go, for instance, to 10. This is 50. Oh, this is 10. And now I can move it and place it in the place I want. So text are exempt. You can move the text on a fine grid, that is fine. But the bins, you cannot move electrical bin on a fine grid. You need to have these bins snap to a 50 or 100 mil grid. So you can easily route them on your schematic. Now, as I told you, if you set your snap grid, for instance, into 25 mil in here, as you can see, now the grid is 25 mil. And you are snapping into 25 mil as the settings, you are moving in that. Now, when you go into the layout or to the schematic here, you need to have your grid set to 25 mil to be able to snap to these pins. Otherwise, you won't be able to connect with these pins, and this is problematic. So that's why I don't go with less than 50 and always try to use 100 mil. Okay, now let's move to the next section. Now the component party or the drawing of the component can be created by using drawing tools. So you have plenty of tools you can use to create a component. And you have shapes, you have polygon, ellipse, pie, circle, you have text, you can add an image to the component as well. Even a schematic component, you can add an image to it. You can do that, there is no problem with that. And to add a component, you need to use the command in the place menu or in the utilities toolbar that we just showed. It was hidden, or the active bar to place these objects, and we will see how we can do that. Let's do some practice on that. So in here you can go into place, and here you have these IEEE symbols. This is like ready symbols with specific size. You can pick up the one you want, and you can place it right away. So if you need an invert or OR gate, for instance, this is an OR gate. This is a symbol. You need to add the bins to it. Oh, it looks like our grid is 25 mil. Let's change it to 100 mil. This is 100 mil as we see in here. And this is ready symbol, and it's brought from the IEEE library. So place IEEE symbols. Here you can see all the symbols you want. And if the symbol is not among these, you can create that symbol. So you have arcs. And whenever you click, so this is arc for instance, double click, escape, you will edit it. Now you can change the arc as well. And the other, if you wanted to control the color and the properties of that, basically double click on it and the properties will come on in here. So now you can change the color and you can change the radius, start angle, end angle, and the location of that. So you have plenty of graphical representation tool you can use in here to make any symbol. So basically you have full circle, ellipse, you can create a line, and also you have a place rectangle. This is will be using more often to create integrated circuit. As you see in here, basically this is a rectangle, and you can click on it. You can change the properties for that. You can change the fill color. You can make it transparent. As you can see in here, it's transparent right now. It's not, where you can see the grid through it. So here you can see the grid through it, and this one is not transparent. And you can control the thickness of the border lines. So make it large, for instance, it's very thick. You can change the color for that. Now tools, let's go back to place. You have all different kind of objects. You can place text frame even within the component to write text for that or whatever you need. So, and also you can add graphic. So this is a huge graphic. We can make it smaller. Let's make it smaller in here. And this is actually, it's nice and handy. If you want to add a logo on the top of the symbol, or if you have, for instance, here, if this symbol exists or this drawing exists in the schematic sheet of this, in the data sheet of the component, basically what you can do, instead of trying to make this drawing, because each one of these is a line, so you can see they made these from lines and stuff like that. And when you create these lines inside, these are not pins. When we talk about the grid, snap grid, 100 mil or 50 mil, we are talking about placing the electrical pins in here. But when you do graphical drawing like that, you can change your grid to 1 mil. That's fine in there, because when you go to the schematic and try to connect with the component, basically you are connecting with the electrical pins. You don't care about these drawings. So these pins are different from the graphical tools you have in here. So when you click on pin placement, this has to be snapped into 50 mil or 100 mil grid, and 100 mil is always preferred, as you can see in here. And the handle where this pin is held is basically the electrical connection. This here, as you can see, you have this cross in here. This is the electrical connection, and this has to be from the outside like that. And here you can connect with the rest of the circuit. Of course, this drawing is very, very nice and I like it, but the other way you do it with the graphic. So basically this is the size. Let's place it like that. And now we'll ask to upload the picture. So the picture can be any of these formats. Let's go now to the data sheet of this component. Let's go to DigiKey, open the data sheet. And this is the symbol basically. So when they created this component, they looked into the connection on this page. Let's take snap. Okay. And let's have, for instance, let's take all of it. Now let's save this. Let's save it. Let's see, where is this place is. I want to search for it for a long time. Paste, save, and let's name it capture. It's okay. Let's keep it as JPEG. Now here is the picture. We can see it in here. Open. Here you go. Now you can, of course resize it, and you can have it in here as a symbol, place it inside a symbol or something. You can do that, of course, definitely. Nothing say you cannot do it. So just example how you can use the graphic. Also, if you have, you can add a logo as well. It's not necessarily just a symbol. You can add logo or something using the graphic. So it's also handy. So you have all these tools you can use to create a graphical symbol for your design. And now let's go back to the slides. Now you can place utility toolbar as well and active bar. So what does that say? It's in here. You can place, these are the IEEE symbols, toolbar, and here you have all different kind of symbols. This is create a component, add a component part, this rectangle, round shape, image, etc. So these are the bins you can. So model manager, we have seen that. So the default settings for the properties of all the objects are defined in the preferences page as well. So as usual, you go to, as always, you go to the preferences, you are on the schematic, you have the default. So the arc, basically these are the default settings, meaning when you create an arc, the default settings for that arc, you will have a small width line, and the radius will be this, and the angle will be that, and so on. Similarly, if you create, for instance, if you have a designator, so you can specify the size of the font, the color, etc. Ellipse, same case, the default settings for that whenever you create something. All that is defined in here. So you can come into the preferences under the schematic default and set the defaults you want for your browser. And as mentioned in session 2, maybe you can always save these preferences and load them if you had to refresh your machine and you have to reinstall Altium Designer, or you move to another machine, so your preferences are safe. You can just port them instead of going and try to change them again from the beginning. Okay. So the component symbol bins, these are the most important part of the symbol creation process. It's how you add pins and how you define these pins. It's always the component pins that give the component its electrical properties. A pin is placed to represent each pin on the actual physical component. The component pin is the only object in a schematic component that defines electrical conductivity. So that's why it's the most important. So the first line here, pins are placed via the command in the place menu or the button on the utility bar, as we already saw in here. So place, you can place a pin. So this is a pin. Let's place it in here, for instance. And now, why this pin has a designator 17 and name 17, designator 18, you see how the incremental sequence is automatic. Once you click, just left click on the mouse and these pins will be added. Escape, you will cancel this comment. So in the same case, you can add pins from this panel in here. So you have a bin in here, you can continue. So if you press tab, you can edit the bin properties while you are holding the command. So if you place it like that, so bin, now while the command is still active and you click on the tab, you get the properties for that bin, which we described earlier. You can change the designator and the name. So the designator in here will be linked into the footprint bad name. So this is very important. You need to know what designator, and this has to match the data sheet of the component. So don't worry about it. We will see how we can create that today. The name, this can be the name of the bin itself. You can go to the data sheet and look at the name of this bin and use it. For instance, here you can see these are the names in here. TX plus, CTX, TX minus, RX plus. These are the names. These now 16, 15, 14, these are the designators. And when we link this into the photoprint, we linked the designator. We cannot see the names, only the designator. Now, electrical property, what is the electrical property of that pin? Is it passive? Is it input or input output? Or it's output, open collector, high impedance, open emitter, or it's a power pin? You need to select that. And usually, all these electrical types are defined in the datasheet of the component. The datasheet will tell you if this bin is input or output, or it's high impedance, it's clock, it's power, etc. So basically, when you create a component, you go to the datasheet and copy the information from that datasheet into here. So no worries about that. We will see that in a minute. So again, by clicking on tab while the command is active, you can edit the properties for that pin. Now, if you click escape or you click on this pause, and now you can place the component after you change its properties. Now, the other way, you can edit the properties of the component or the bin after placing the pin as well. By basically, if you can right click on it, go into properties, or double click on it will do the same thing as well. You can edit the properties at any time as long as you are in the editor, component symbol editor. Now, numerical value will be arrow incremented on the sequence pin placement as we saw just now. So why did we start from number 17? Usually it's to start from number 1. So how we can, why? Because we have 16 pin already placed. You cannot have the same designator for 2 pins on the schematic symbol. If you do 16 in here, for instance, for this designator, and when you combine it, you will get a warning in here that will tell you your 2 pins have the same designator, meaning these are electrically connected together. So be careful about this. So this has to be 17. Okay, so the auto increment settings can be changed also in the preferences. If you go to the schematic, if you go to, this is the schematic. If you go to general, enter general, you have auto increment during placement. So increment by 1, as you can see, it's defined primary and secondary. If you do 2, now if you place pin number 1, then you will get pin number 3, 5. You place number 2, get 4, 6. It will be incremented by 2, but always we have it incremented by 1. So this is how you change the default settings for the incrementing number. During placement, the bin is held by the electrical end. This also we mentioned this, called the hot end of the bin. This is where the bin is connected to the rest of the circuit. Now let's place a pin. Tools, place pin. You see where the bin is connected. Let's zoom in a little bit. You see the cross? This is the hot spot or the electrical connection of the bin. This has to be to the outside of the symbol. Like if I'm on this side, this has to be like that, so it's accessible. Let's expand this body a little bit. So this is accessible by the other part of the circuit to connect with it. Now you can see here the connection points in here. You see these 4 dots. Now I can copy this, then paste that. Now if it's on this side, you need space, you need to flip it to the other side. Now it's accessible also from the other side of the component. If it's on the bottom side, you see where the component is held. This is the electrical bin or the hotspot. It has to be also accessible to connection wherever the bin is placed. Always it should be to the outside. Now when I go to the schematic and I would connect, control start connection, and let's say you see how the cursor is changing to red and snapping into that bin because it's in here. So if you move here or here, you don't see this red cross in here because this is not electrical properties or not hot the hot pin in here. hot end. So if you start in here, you come closer, so it snaps automatically. You see, I'm 100 mil distance, it snaps automatically to the electrical connection of the bin. So now it's connected. You can tell that it's connected. Okay, let's go back. So this is very important point. Be careful when you create a component. You need to make sure you can see how this is the plus or the cross in here. It will tell you that this is the right bin. If you place the bin like that, for instance, and this is wrong, now the connection is inside, and this is not the hot, what is called the hot end. This is not the hot end or electrical connection end. It's in here now, and you have problem in this library. But when you try to do schematic and connect by mistake, you connect with this end and do ERC, that the compiler or the ERC engine will tell you that there is no connection with this bin, and you will know that it's flipped. You need to correct this library. So let's go back. So the bin must be positioned so that the electrical end is away from the component body. This is what we talked about. So the electrical end is away from the component body, regardless of if the bin is on the right side, left side, top side, or bottom side of the component body. Now, under the space, use the space bar to rotate the bin while it's being moved, as I mentioned as well. So if you move component, space bar will rotate this component in an increment of 90 degrees. So a bin has several properties, including display name, electrical type, and designator. These are the most three properties of electrical bin or a bin. And display name, again, it shows the identification of the name of this component, can be copied from the data sheet. So this component is input. It can be, let's say, for instance, in here is receiver plus, transmission plus is the center tab for the transmitter, center tab for the receiver, etc. And then in electrical type, it's input, output, passive, high impedance, open collector, open emitter, all different kind of component type. Also, you can copy this information from the data sheet. You don't have to, because basically the manufacturer or creator of that component is the one who defined the electrical type of that pins. And the designator has to be unique. So the bin designator is used to match the symbol bin to the PCB footprint pad. Also, we already mentioned that. So a bin electrical type is used by the electrical rule check engine to verify that pin-to-pin connections are valid. So that's why you need to define the electrical type of the bin. If you don't define it and all the bins are passive, a lot of the electrical rule check will pass, even if they are not correct. For instance, if you are connecting an input pin with an input pin, this will show a warning when you do electrical rule check, because it's defined in the ERC matrix, error matrix in here. If you recall that when we talked about tools. Oh, we cannot see it in here. We need to create a project. Let me create a project very quick. New project, default. So let's move this schematic to inside this project. Okay. Now go to the project options. Here we go. And you have connection matrix here. So when you talk about input pin or input bin in here is connected to, for instance, unspecified port or input sheet entry or unconnected, so you get these errors. If you have an IO bin connected to input bin or output port or power bin, you get warnings. Now, how basically the bin type is used to check for these errors. So you need to define these in the library when you create a component. It's very important. Now the component symbol properties, we talked about this as well, and just as I said, this slide just a reminder for you to do a follow-up and try to study this video. So the symbol name is defined in the design item ID as we see in here. Always, you can put any design item ID. First, it has to be unique for all the components in the same library. You can use the same item ID if you have a different library, but for all the symbols and within the same library, you need to have unique item ID for every one of them. So basically, just use the exact part number of the component. So when you search for a component within part supplier, you just copy the manufacturer part number and use it as an ID. Design item ID field. Designator, we will talk about the designators. Designator, there is a standard in the IEEE define the initial letter you can use as a designator for most of the electronic components. We'll talk about that. So when you see T, that means transformer. When you see Q, that means transistor. When you see R, that means resistor. C for capacitor, L for inductor, and D for diode, U for integrated circuits. All integrated circuits use the same letter U. So you can add descriptions. Let's go into the schematic and talk about it in here. So you have a description, and you know that you don't have to import these parameters, even the design item ID, that this will be imported automatically as we saw in session number 6, because you can go into the manufacturer part search and search for this component. Let's see, where is it? Here. Copy, paste, search for it. Of course, it doesn't have a model, schematic and photoprint model. That's why you need to create that. So basically, you can import supplier link and parameters into this component you already have in here. And let's do that right now because it doesn't have that. When you import that, we need to hide these, of course. You go to the properties now of this component. You can see there is a link, and if you go to the parameters, you can see supplier information. This is the supplier part number, supplier's DG key, and these new parameters were added. So, and even this one and this one will be added automatically. The only things you need to add is the designator and the comment. And my advice is always use the design item ID as a comment, because when the comment show on the schematic, when you place the component like that on schematic, so this is the comment. The comment is basically will show the part number. If you print out your schematic and another engineer trying to review it, basically he can identify the part number of this component by looking into the comment. It's very easy to find out what component you used and go and look into the datasheet of these components. So the component symbol properties, let's talk about these or component types. Let's go back to the symbol in here. Let's remove these pins that we created, extra pins we created. You can just select and click, and let's hide this value, which is description of the component. You can basically click on it and click on the eye, and it will be hidden. Or you can go to the properties of the component, parameters, and this you see it's shown in here, description. You can click on it, it will go away. So when you click on the component, select the component, and here you can see there is a type of that component. If you click on this menu, now for most of the component, like 99% of the component or even 99.9% of the component you create, these will be standard component. This is the standard. You can also create a mechanical component, graphical component, net tie that included in the bill of material, net tie that is not included in the bill of material, and a standard component that will be not included in the bill of material, or you can create a jumper. Now, what is the difference between all these? Now it's true that standard component is standard component. Now let's take a look. I put the description for all of these for your reference. So basically the standard component is standard electrical component loaded onto the board. They are always synchronized and are in the bill of material. So meaning by synchronized, they are always synchronized between the schematic and the layout. So if you have a symbol in the schematic, you always have a footprint in the layout. And the bins of the schematic, they have a matched bad on the layout. So if you change this component on the schematic, it will change on the layout as well. So that means what means by synchronized. This is the standard component. This is what you use all the time, and this is what we have been using in our demonstration projects. Now, for mechanical component, these are non-electrical component. Of course, it says mechanical. That means it's not electrical component. But why do you need it? For instance, if you want to add a heat sink, or add mounting brackets, or add fiducials for PCB assembly, or add any other mechanical identification symbols, you can use as mechanical, a type of mechanical. Why do you need to do that? Because the ERC, electrical rule check engine, will not go and check this component electrically, because this component doesn't have electrical bins. It's just a graphical representation of mechanical function, and is defined as mechanical function as well, and this will be synchronized as well if exists in both schematic and PCB. It can be only schematic symbol, it doesn't have to be synchronized, but if you create a heat sink, you need a symbol for a heat sink. It's just block, small block, and this heat sink has to have a physical representation on the layout as well, where you need to place the heat sink. It doesn't connect to anything because it doesn't have any electrical property, but it has a place where it will be mounted into voltage regulator or transistor or something to cool it down. So it has a physical property on both on the PCB layout. Now graphical, it's just it can be company logo, title block, etc., and it's not synchronized. And so because it's just graphical representation. Net tie, and this is, it can be transferred to the bill of material, and basically this is used for shorting two or more nets together in the routing process. And we can talk about this more in details later on, because it's a little bit a special subject to talk about net ties. It's not very common subject for most of the PCB designer, but sometimes it's very important. One of the example of the net tie, if you have analog ground and digital ground, and you need to connect these two with a net tie, and this net tie could be a 0 ohm resistor. Now this 0 ohm resistor exists in the bill of material, but it's defined as a net tie in the schematic, so the ERC can check this as a net tie and not tell you, oh, okay, you are shorting the two grounds using 0 ohm resistor. It's not 0 ohm resistor, it's just a net tie. So the net tie also could be not included in the bill of material if it's just a wire on the PCB or a trace on the PCB layout itself. So it can be net tie without bill of material standard. So this is exactly similar to standard electrical component. It has electrical characteristic, it's synchronized, everything is the same, except this component will not be included in the bill of material when you generate bill of material. So why is that? If you have a component that is marked DMP, meaning do not place on the layout during the assembly process, this component can be identified as standard no bill of material. Now, at what situation you will have a component in your design that is not placed? In so many situations. If you hold any printed circuit board and look into the printed circuit board, you will see a place for a component that are not populated or not assembled into the board. Why is that? Because sometimes you have to design a board to work in different products in different configurations, and also to account for different functions. So basically you can place a component in a specific configuration for a specific operation or features of the board. So, and we do that all the time when we do a design. So instead of doing two different design and making two different boards, we do one, and we have a component configuration on the board where we populate some of the component and skip the others or do the other way around. So what is the benefit of that? It's saving factor. So instead of making, let's say, 10,000 of PCB-A, 10,000 of PCB-B, if you can make one PCB that can work for both, but the difference is the assembled component, and you will save a lot. Now you can make 2,000 of the same board, and you can save 15 to 20% of the cost. So jumpers, basically it's a jumper, and these are the old style. If any of you have done single layer PCB, where sometimes we have to use a jumper to connect the trace when it's crossing multiple traces. Basically you use a jumper to switch to the top layer and go back to the bottom layer because we don't have traces on the top layer. So let me see if I can find an example to show you what I'm talking about. Single layer PCB using jumpers. Images. This is a nice example. This is how you see it in the layout. These thread ones, basically these are jumpers, and this is what you see. Now these wires, bare wires, these are jumpers. Basically they connect traces on the bottom layer similar to this. These are jumpers, as you can see in here. This is the jumpers. Basically, instead of creating another layer on the top, you can put wire from here to here and solder it on the two sides, and now you are connecting this trace into this trace here. Also, you need to connect the ground in here into the ground in here, and because you have two wires in here, you cannot do this connection, and there is no way to do it from different sides. So basically you put the jumper to connect from here to here. So this is very common old style or old-fashioned PCB design we used to do all the time when we do single layer PCB. And why do we need single layer PCB? Because most of the small prototype we used to do long time ago, we used to use a routing machine or use chemics to dissolve the copper and have the traces without going into fancy PCB fabrication, because the PCB fabrication was not available the way it is today at this low cost. Because now you can get the PCB 10 centimeter by 10 centimeter for $1 from PCBWay or other companies like similar. They have the same business model as PCBWay. Talking about PCBWay, if you are not familiar with it, just take a look at it. So $5 you get 10 pieces, 1 to 2 layer, build time 24 hours. This is crazy. This is really crazy. So it's super cheap right now. Okay, so this is the component types in a nutshell. So adding parameters, we can take a look at this. So let's go back in here. So you know the parameters. We imported these automatically from the manufacturer part search by right-clicking on the component, import supplier link and parameters. What if the component doesn't exist at all in the manufacturer part search? What if I want to add a special parameter to that? You can do that. It's very easy. Click on add. You have parameter. Let's name this parameter, for instance, build number. And I can call this one build number A. And I can have build number B and so on. And this can be dynamic parameter. I can change it at any time. So this is how you can add a parameter to it. And you can change, of course, the font type and color for that parameter from here. And if you have multiple components in the libraries and you want to add common parameters for all of these in the same time, basically you can go into tools. There is parameter manager somewhere in here. Here we go, parameter manager, and I need to look into the parts. You can of course look at the names, etc., but I need parts or components. Parts mean components in here. If you click on the components, you will see these are the 4 components available in your library. and they exist in the my library.schematic library document, and the type of these are parts, and these are the parameters in here. You see one of them has a build number A, which I just created. So basically you can copy this and paste this into all these. Now the green, that means this has just changed and has not yet updated. To update that, you need to generate the ECO, engineering change here. You click on it, and once you click on it, it will tell you these will be added as parameters to these component, execute. Now if you check these component, all of them should have the build number parameter in it here. Now let's go back to the component tools, component managers, tools. Parameter managers. Okay, so here you can see different parameters for the component. So you can change any of them at any time, and you can add new one. It's called column. So if you need to say this is revision or created by, add to all objects created by Walid, let's say Walid. So now you have new parameter, accept the changes. This parameter will be added to all these components, execute, and here you can see the parameters. So now if you have a library with 1,000 components and you would add a parameter to all these, it's not efficient to go to these components one by one and try to add parameter to each of them. No, it will take forever. So you can just go to the parameter manager, select part, and here you can edit or change. It's just copy and paste. It's very handy, very easy to do it. So if you click on clear, you can remove it. If you change one of these, just copy and paste. You can just copy and paste. So Walid. So if you click on Control C, select all these, Control V, it's changed. This is very, very handy. So we don't want to change this one. Okay. So let's go back. This is for the adding parameters. Now, multi-part component. We talked about this, how we can have a component with multi-part. So some of the libraries, if you open a library like that, or before we do that, let me show you something what I'm talking about. And if you go to schematic sheet like that, let's remove this component from here. So let's go to the manufacturer parts. Let's search, for instance, for LM324. This is old style quad operational amplifier. So we have this component in here, as you see. Let me expand this a little bit. And okay, so if we open this in here, so you'll see the information, parametric information about it, and you see the schematic symbol. And look here, now you can see that there is part A, part B, C, and D. When you click on the other parts, the bin numbers are changing. Not only that, if you start with part A, you will see U, which is the designator for integrated circuit, question mark. This will change when we do an annotation, and A, this is part A. Then the same thing, but it's part B, C, D. Now if you click on part A and place, the first component will be selected. Okay, updated. When you click on it, now you see it's UA. Now if you look at the designator for this, it's U question mark B, which is the second part of this component. Now place it. Next one, C. Now D. Now start again. It's U, A, B, C, and D. Now let's do an annotation for this. Annotate schematic. Accept, execute. Now let's take a look. So this is U1A, 1B, 1C, 1D. All these parts or subparts belong to the same integrated circuit. So they are on the layout one physical component, and these U2, A, B, C, D belong also to another component. They are one component on the printed circuit board, meaning you have now two integrated circuit. But so how we can create a component with multi-parts like that, similar to this? So let me show you. So here, if when you click on this, this will tell you this is part A of 4 parts, and you can edit this and you can now change it. You can say this is part B, but you need to be careful. Now when you do this part B or part D, look at the bin numbers are changing, and in this case you need to come to part B and make this part A. You cannot use the same things. So UA, UB, oh, this has to be UB because we changed the first one, and now there is no error or red line or red zigzag line as you saw earlier. So you can swap that, you can change that, it's okay. This is what we talk about multi-part. We will see how we can create that similar to this thing. So you can add new part from the tool. We will see that. So this is another example where you have a NAND 2-pin 2-input gates. So these all are within one integrated circuit, and this circuit has 4 NAND gates with 2 inputs for each. Now let's try to implement this component, and this will be our first start, or before that I prefer let's try to build simple components like a resistor or something. So let's create add new another schematic library within the same package. So this is something new I would add here. So, and also let's create new PCB library within the same library package. So can I do that? Yes, you can do that. You can add as many schematic libraries or PCB libraries you want within the same package. Now when you compile this and convert it into an integrated library, what will happen? You will get one integrated library, and you will get all these components within all schematic components and all their associated footprint within the same library. They are not differentiated in the integrated library. So the integrated library will be a container for all these different schematic libraries and footprint libraries. But why this one would be helpful? If you are creating a library that has, let's say, a sub-library, schematic library for passive component, and the library for analog component, and the library for microcontroller, and so on, you can do that all within one integrated library. But now you know that this schematic library is dedicated, let's say, for resistors or for passive component, and this schematic library is dedicated for integrated circuit, and the other one is dedicated for, let's say, analog components or operational amplifiers. So when you come here and edit, it's very easy to handle these parts or transfer these parts between the libraries. So let's save this one, this library, and let's call it passive. So save it in the same place, and also let's save this. Give it the same name. Now this is our library. Go to the schematic. The first thing we need to create is to create, let's say, a resistor. Let's add a resistor. Basically, you need to have a package, a place, a package for the resistor. If we want to do the so you can leave this, you can move it like that. It's in the center, and let's add 2 pins to it. And place pin. Now we need to tab. Let's call this. This will be a resistor. You don't have to change this right now, but the designator. Let's call. This is not okay. This is for the pin. So designator, this is bin number 1, and the name for resistor is bin number 1, and you see it's too long bin. Let's change this one into 100 mil for resistor. This is the bin length here. So we can change it later. Remember, the electrical or hot end has to be from the outside of the component. Place this one in here, and now we can resize this package, the body of it. So the bins are placed on the 100 mil grid, and for these just drag back, and really we don't need a bin identification or the designator to show. Basically select the two, go to the properties. You don't have to show designators and name for a resistor. It's nothing important about it. So this is basically the European symbol for a resistor. Done, that's it. What if I want to change this into blue and make this small, and I don't need any fill color inside? I see this all the time. They like it to be blue. Okay, done. You can save now this, and if you go to the schematic, and this is a component number 1, but we don't have any information about it. Basically, you can populate this. You can say this designator has to be R because it's the designator for resistor. But what is the design item ID? I told you to have or to use the part number, exact part number. Let's say this is a symbol. I go to the manufacturer part search. I can do that manually, or I can grab it from here. Or let's do it manually first. So let's say this is, let's search for it in here. So res SMD 100K.4.2. So this is the resistor I want, right? So this is the part number for it. If I click on it, it will take me to the Octo part where Altium Designer store all these information, and I will see the part number for this. So this is the resistor I'm creating a component for. Basically, I can go to the properties of this component and put this as a design item ID. And I know it's gonna be unique because I don't have to create two resistors in the same libraries, two same resistors in the same library. Why? You want to do that? There is no way. So comment, as I told you, you need to have the comment as I recommend that to have it the same item ID. Description, now you need to go into the description. You copy this description. It's resistor, SIG film, etc. This is a resistor. Now this is a standard component. Yes, it's a standard component. Links, I need to add a link for this. So basically I can do, let's call this data sheet, and I can go here. I can copy the link for the data sheet, place it in here. Okay, I can add another one. Let's suppliers, and I can copy the link for this Octoparts. I can go in here, add. I have it in here. Now photoprint, I don't have a photoprint yet. I need to create that. We can add it later. So basically, you can add it from here or from there. If you want to add a simulation for a resistor, you can click on it. There is a resistor simulation. Model name resistor. Semiconductor resistor. It's not variable. The value is 100K. Port map 1 to 1, 2 to 1. Okay, I added the simulation model for a resistor. I still need to add a footprint for that, but we have not yet created a footprint. Now let's save this. It's saved. Now you can see the value in here. If you want to move the value, you can move it in here. Now let's go and add some parameters to it. Now in the parameters, you only have the value. You can add, let's say, tolerance. What is the tolerance on this? It's 1%. Let's make sure the tolerance is 1% on that. So it's 1% tolerance. Let's say power. Here, add power. It's 1/10 watt. Let's add package. It's 0402. We know all these information in here. Or one way to copy these, click on the DG key. You can go to the DG key and here is the attributes. You can copy these attributes, and basically these are the parameters you need basically in here. So the size, etc., the temperature range, the temperature coefficient, etc., composition. These are the parameters you need. So you can copy all that into here. Or what is the other way to do it? You can go to the manufacturer parts here, right-click, add supplier link, and parameters to this component I'm editing right now, which identified by the item ID. One click, go to the properties. Now you can see that the links are updated. You have all these links for this component, and also this was updated. Parameters, look at how many parameters you have. Instead of having these entered manually, now in one click you got all of them available for you. So it's very simple and very easy to do it that way. So we have just created a resistor component. Now what if I need to have the other symbol for resistor? You remember when we talk about the US symbol and Europe symbol? So what if I want to add the other symbol for the same resistor? Do I need to go and create another component under the same properties, under the same design item ID? I cannot do that. So what are my options? You see here the mode. This is a normal mode, and you have a plus or add and minus or remove. Or you can go into tool, mode, add mode. For now you see the normal mode or the default mode, which is this one. When you click on add, another schematic editor will open, and this editor is integrated inside the same component. So if you click on backward or forward, you will see the symbol. Still, we don't have a symbol for the second mode. So basically, let's copy these pins and go into here. And this is 100K. Let's place these pins in here. And now we need to create the other symbol or the body of the component based on the new one. So place, line, and let's click on, we need it blue, etc., etc., etc. Okay, that's what we need. And now we need to make it like a zigzag. But we can like that. So how we can change the direction? Shift spacebar. Shift spacebar. Now we need 45 degree, and we need the grid to be fine. So we click on grid. It's 10 mil right now. Now we can do like that. Like that. And you can make it better. It's just something very quick. Now this is the second symbol. Now if you go to the properties, you still see all the same properties, same parameters, nothing changed. If you switch between the symbols in here, you can see the first symbol and the second symbol basically is different graphical representation of the same symbol. It's mode. It's another mode. So if you go to tool, mode, alternate one, you can have, I think, up to 255 alternate representation or 255 different modes for one component, for the same component. This is how you create that. So if you can add another one, you can have a different representation for this mode. So the bins, when you click on the bins, they have the same designator, the same name. They are not changed. So you cannot change them. If you change them in here, they will change on all the modes. It's not like you have a unique bin number for different mode. Again, this is just a graphical representation in the schematic only. So on the layout, you have a physical component that has two bins. It doesn't matter if the symbol is US style or Europe style. It doesn't matter. So it's just a graphical representation in the schematic symbol. And here maybe I can add place. I need it to be resistor like, for instance, like that here. or whatever, it's okay. So now I have three different modes. So normal, which is the default, alternate one, alternate two. So let's save this. Now let's go to the component we created and click on place. So it will come in here. So how can I change the mode in here? Just click on this component, and here, graphical, normal, alternate one, alternate two. This is how you change it. Just the properties on the component on the schematic when you place it on the schematic sheet. If you go to the component, you just can see it in the different modes as well. Okay? So if you click on the properties in here, you won't see the mode option in here. The mode option here, you can change it only from the tools mode. You can switch between the different alternate modes, and you can see the normal or the default mode. This is the default mode. Whatever you want to be the default when you place the component in the schematic, you can place it on the first one, on this in here. Okay, this is about the mode. So we started with small resistor. Same case you can do for caps. So how we can now, let's go back to our origin discussion, how we can do multiple parts. So now we did different modes for the same component, different representation. So how we can do multiple parts. So same thing, let me show you. It's very simple. So if you want to do multiple parts, let's create new parts in here. Add. We have new parts. Let's not give it a name right now because we can import these parameters and change it later. It doesn't matter. Now we have parts in here. Now if I go to the, I need first to have access to the data sheet. So I'm looking for LM324. This is from Texas Instruments. Let's take a look. You can go to the company website, open the data sheet, and as you can see, it's quad operational amplifier. And this is the data sheet, and here you get this component is available in different packages. So you have through hole and surface mount. It's very old component, and here you can see the difference in size between these different packages. So basically the smallest package would be the TSSOP, and the number between parentheses is the number of the bins of the component. So 14 meaning you have 14 bins distributed on two sides, 7 by 7. So this is the symbol for each operational amplifier. You have negative input and positive input, and you have an output, plus you have the supply for the whole chip. So you go down here. So you have 4, and each one has input plus, input minus, and output. And this is the chip, basically. So you have 1, 2, 3, or you can go to the table, which we will be using. So the first one, if you are, this is a unique situation. This is a different package, LCCC, which is this one. Let's forget about this one for now and create for this one. So all these different packages, they have this, they have only 14 bin. This package specifically has 20 bins instead of 14. Now let's create a component for the 14, not the 20, because this is a unique situation. So we have input 1, plus and minus, and the output 1. This is the first stage, or the first operational amplifier inside the chip. This is the second one, 2 in minus, 2 in plus, 2 out, 3 in minus, 3 in plus, 3 out, and this is the fourth. And then you have bin number 16, bin number 11 represent the ground, and bin number 4 represent the power supply. So let's create that. So the symbol will look like that. Let's go in here. So how we can create that, remember, if you go back to this sheet, this is how they created this. So input, output, and power supply. Let's go over there. This is not passive, but we can put it inside the passive. We are just practicing, okay? So tools, place. Let's see in the IEEE. You can change it, or let's create that here. Let's see if we have. We can do line like that, and let's set the grid to 100. This is 100. So we will have 2 bins in here. So let's create that like that. You are just drawing. You can have it like that or whatever. This is the first part. Now you need to add bins to it. Click on place pin, or from the toolbar in here you can have a pin in here. So remember the electrical snap to the outside, electrical hot point to the outside. So 1, 2, space, you need the output pin, right? If you go back in here, so 1, 2, output, and similarly to what they created in the library, 1, 2, and this is the output pin. Now you don't want to really show the comment in here, so you can hide the name of that pin. I will show you an example where you show the pin, usually for integrated circuit like microcontroller or stuff like that. So you can hide the pin. You can select all and click on this, it will be hidden. Now let's take a look. What is the order of these? For the first stage, part number A, so the N minus is bin number 2. Be careful about it. Now let's put the properties in here and let's tuck it in here so we can have access to it. And now let's click on this component. So click on the first bin. So this is the name. It's you go here and copy the name. This is the name. It's not shown, it's hidden. We hide it. So bin number, and this is bin number 2. Don't mix this, forget about this for now. It's bin number 2. And the type, it's input. I means input, so the type, it's input. Now see, look how the bin shape will change into with an arrow to indicate the inputs. Now we need to make these pins 200, make it longer a little bit. These short, and they saved the last settings when we created the resistor. We had them 100. Now same case for number 4. We need to see, so the 1 in the plus, the second bin belong to the same stage. It's bin number 3. This is the name. This is the designator, and it's input as well. And description, don't forget about it. So it says positive input, just copy it. Description, enter it, and this one is basically negative input. Copy, paste. We have description for it. Now, when you go to the schematic and hover with the mouse over the bin, this is what you will see. Even in the library, it will tell you bin, and it's 2. It's 1 in minus, and the type of it or the description, it's input. And in the schematic, you will see the description of that bin as well. And or if you go to the bin editor, you will see the description for that bin as well. It will be helpful for you. So the last one, the output one for the first stage, so 1, 1, 1, these are first stage. It's bin number 1. So we go change the designator to bin number 1, and the name of this is 1 output, and it's output bin because we can see here it's output, O output, and the description we can add output. Oops. So we are done with creating the first part, which is U2A, this one. So we had 2, minus 3, positive 1, the output. These are the power supply. You see all of them are the same number because you can connect with any of these. If you go back to the data sheet, so bin number 4 is VCC, bin number 11 is the ground. So 4 VCC, 11 ground. I don't like the way they created this library. This is not how it should be done, and I will show you how this should be done, because now all these have the same designator. And when you do check or compilation for the schematic, you will get a warning. It will tell you, oh, these have the same designator and they are connected to the same net. And you need to override that a warning. But the other way to do it, I will show you how you can do that in a minute. So we have just created the first stage of this chip. Let's go back. This is the first one. So how we can create the second one? Copy this, select all, Control C, or you can go to Edit, select all, Edit, copy. Now go to, let's open this let's drag this in here so we can see it. Now go to the tools, click on new part. This new part will add a subpart underneath this one, and this will be named part A. Now you see this? This is part A and part B. Add more parts because we need 5 subparts. New part, C, tools, new part, tools, new part. So these are the parts you can see in here. We have all these parts. Now go to part number B. So we have part A, part B. Let's place it in here. We need to change these now. Let's place the rest and we can change them all together later, because this is how you can create a component with multi-part very fast. Copy and paste. Part E is basically the power supply. We'll talk about that. So part A, it's 2, 3, 1. Part B, let's say, go back to the data sheet, it's 6, 5, and the output is 7. So just change the designator. 6, and this is 2, right? This is now the second one. And this is 5, and this is the second input. And this is 7, and this is the second output. So I'm just changing these. These are the same. This the same, then the same, everything the same. Now let's see the third stage. It's 9, 10, and the output is 8. Let's go to the third stage. 9, and this is the third input. 9, 10, 13, 14. Okay, this is 9, 10, and this is the third. 9, 10, and the output is 8. So this is the output is 8, and this is the third output. And now let's go to part D. So D is the first one, so it's 13, 12, 14. So the first one is 13, and this is the third, the fourth, and this is 12, this is number 4, and this is number 14, and this is number 4. 14 is output, yes, it's 4. What left? The ground and VCC. Instead of doing what they did in this library, which is it's not recommended to do it like that, and this is not good practice, and I hate to see library like that because it will give you a hard time when you do electrical rule check. And now you need to connect every one of these to the power, and given that all of them are the same net, so there is no reason for having all these on every single stage. It's just 2 pins. Why do you want to duplicate these? So what you can do, basically you can create a part, and this part is for the power. Now you can add first pin like that. So remember, electrical property to the outside, and you can add another one from the bottom side like that. Now you need to hide the name, given that we need to change it, and we go back. The ground is pin number 11. So let's start with this. This is ground, and it's pin number 11, and it's power. Let's go back. So it's called ground. Let's change description. It's ground. So the VCC, it's power supply, and it's pin number 4. So this is a VCC, it's pin number 4, it's VCC and the description and its power and its power supply. Now we have these in here. We can use them. So this is the first part. Now look at here. So you have a component, you have 5 parts of that, and you can cycle through these. Now let's go to the properties of that component. Now designator, its integrated circuit, U question mark. Let me show you something very quick before we move to the next step, which is about the designator. Where are the designator? Here. Let's take a look at reference designator. If you open this Wikipedia on reference designator, this is a nice page, and it will tell you these designator are defined in the IEEE 315 standard, and here is a table. So if you are not familiar with these designators, here where you can find a list of all of them. So for integrated circuit, if you go to U, integrated circuit ICs, you use letter U. For resistor, for instance, you use R. If you have a network resistor, which is multiple resistor inside the same package, you could use RN, resistor network. If you have thermistor, you use RT, and so on. For transformer, you use T. For transistor, you use Q. For capacitor, you use C. For diode, you use D. For fuse, you use F. And for inductor, you use L, and so on. So this is a nice list. Remember this link and spend some time to review the content of this page. So this is how we can know the designator for a specific component type. Okay. So we don't want to create these parameters manually, because if we go to where is it? Here. So if we go to this sheet, we need to import these parameters manually, and it's a headache. So what we can do, we can go into the manufacturer part search, and we are looking at M324. Let's pick up the right package, make sure it's the right package. And this is the package we want. It's SOIC 14. It's exactly. And what we can do, right click on it, import supplier link and parameters to component 1. And here we go. Now we can go back to the properties. Component number 1, we need to have parameters. This is the manufacturer part number, copy. This is the component we want. Use the same manufacturer part number for the comment, and for the description, the description also inside the parameters, you can see it, or here you can copy description from here, or if you go back to the manufacturer part search and click on this, it will take you to Octopart website. Oh, it took to, okay, for some reason it took to the manufacturing company website. It's okay, but here you can find the description for that, or you can take it from DGKey from here. So it's IC operational amplifier. It's 4 stages with 14 SOIC package chip. So you can go in here to the properties, and this is the description. Enter. We don't have a footprint yet. We are gonna create that today, and the parameters are in here. We don't want to show the description, and we don't want to show the supplier part number for that. So the component is ready. Now let's save that, and let's add schematic sheet. We don't want to save schematic sheet. It's okay. Let's go back to the project. Okay, project. This is saved. Okay. Now let's place, go back to the component, let's click on it and say place. Now look, so we have this number 1, 2, 3, 4, and you have power supply. So You can see that. So instead of having these pins here and here all the time, now you have them. We don't need to. Okay, so it's one. Now you can connect the power supply in here right away. Here, you just click 11 is ground. I know that from the data sheet, and this would be the VCC, and done. Otherwise, I will have to do that for all these pins in here, for every single one, and these are redundant, just redundant pins. It makes no sense at all for me to do that. So this is how it should be done. This is much nicer, and this will not create an ERC error when you compile the project. Look how nice it is. Now, what about these plus and minus? These basically are just graphics. You can add them here. So let's go back to the library just to identify the negative and positive part A. So you can add place, text string, tab. I need it to be blue, and I need plus, and let's bold, and we can use Arial black like that. Okay, and you can click on Control, and you will get the fine grid now. Plus and tab minus, click on, it's a negative. Now you can copy this one and this one, Control C, go to B, place it, go to C, Control V, T, just paste. And here we could add some description. Let's call this VCC, and it's large a little bit. Let's make it small, and we can call this ground, and let's make it smaller and put it here like that. It's nice. For VCC, let's change it to red, and we can place it in here. Now here is the new things I want to teach you, which is look at the component right now in here. So let's go back how we can update this. You can go in here, you have updated your library, but it's not yet updated on where it was used. Right click on it, update schematic sheet, click 5 component, 1 schematic document. If you go now to the schematic, here we go, it's updated. You can see VCC ground, and you can see the plus and minus on all of them. So we have created a symbol. We have learned now to create a symbol with multiple modes, like the resistor, when we created the resistor in here. So this resistor has a multiple mode, normal, alternate, when it will change right way in real time. And also we learned how to create a component with multiple parts. So this is a good progress in my opinion. So let's go back to our slides. So this is how you can create a component with multiple parts. And for alternate view mode, we just talked about it when we create 3 different view modes for the resistor. So basically you can create up to 255 alternate view modes for one component, for the same component. And as I mentioned, each alternate view mode should always have the same set of pins as the normal or default mode. The normal is the default mode all the time. You basically just copy and paste these pins into different modes, and these will have the same designator, same description. Everything will be the same. It's just copy and paste. So you can show the mode toolbar from the tool, or you can access the modes from the tool modes and from the mode toolbar as we saw here. So tools mode, you can add, edit, change, or from here, from the toolbar in here, you can add the different modes to the same component. And once you have a component with multiple modes, you will see these arrows will be active. And if you go to the tools mode, you will see the available modes for the same component. And again, the normal is the default one. When you compile the library and go to the schematic and place this component, the default one, or the one you will see, is the normal one. And you need to go to the properties as we saw, click on the component and go down, and you will see graphical. You can change the mode in here. Okay, So model manager, we talked about the model manager. So if you have a library with multiple components, if you go tools, you have model manager, you can basically add footprint to all these components. If they, for instance, if you have resistors, as we said, or capacitor, inductor, they share the same footprint, and you can just select the ones you want to edit, and you can add a footprint or remove or make an edit for these one time. So this will be very handy if you have a lot of components share the same similar footprints or simulation model or something like that. And update from libraries, I showed you how you can update. So right click when you edit a component on the library, right click on it and click on update schematic sheet. Or if you are on the schematic sheet, you can go to tools and click on update parameter, update from libraries in here. It's the same thing. You can do it from here, from schematic, or you can do it if you are on the component editor, you can do it from the component editor in here as well. You can click update schematics here. You can do that in here as well. It's the same thing. Now, reference designator, you have this link, and I encourage you to do a review just to learn these reference designator if you are not familiar with them. Let's go to the next. Now, the symbol wizards. This is a nice feature. I think was added to Altium Designer 18 and later version of Altium Designer, and it's available in the schematic. Basically, it's provide like a tool to create a schematic symbol using a wizard. So you don't have to draw things or add bins manually. You just start the wizard and create these symbols. And let's take a look at that. So I'll go back to Altium Designer. Here. So let's create new. I don't have to create a new symbol. Actually, it will automatically create. If you go to tool, now before we go to tool, this is like an add-on. It's a plugin you need to add to Altium Designer if it's not installed by default. So this is the extension. If you go to once you go into the license extensions and update, you need to search for it. Let me see. So it's called Schematic Symbol Generation Tool. So here is the tool. Here is the extension. So it's installed. You can see it. It's in here. It's installed. If it's not installed, it will be under purchased. Here you can click on this arrow and it will be downloaded and installed into Altium Designer. So let's close this one. So by default, I think by default it's installed in Altium Designer 18 or 19 and latest version of that. So you go Tool and Symbol Wizard. You click on it. Now let's go and create. Let me open a data sheet for a component. Let's say STM32F0. Let's find a small microcontroller. I don't want to spend a long time creating footprint for big microcontroller with so many pins, embedded microcontroller. And let's take a look for. I prefer to have QFN. Or LQFP, that's fine. LQFP 48 pin, no, it's too much. Maybe 25 pin, 28 pin is good. So let's create that for this QFN 28 pin. Okay, apply. Let's see what component has. Okay, this looks nice. So we need this component. Let's open the data sheet for this guy in here. Or maybe this might be difficult. Let's go with a QFP is good start point for you. So this is QFP. It has more bins, but that's fine. So this has 48 bin. It's 7mm by 7mm as a package. So let's take a look at it. Okay, so the same component has multiple package. That's why you see it in here. So we are looking into LQFP 48 pin, which is the microcontroller we want. So a bigger footprint, meaning you have more bins, you have more functionality on it. So this one has 64 bins, this one has 100 bin LQFP, and the dimension of it is 14 millimeter by 14 millimeter. Now this is different footprint that has 48 bin and is 7 by 7. And this is BGA bin. Basically it has 100 bin and the size of it is 7 by 7 millimeter only. So imagine 48 bin is 7 by 7 and 100 bin is 7 by 7. That's mean now the pitch or the spacing between the two pins or two bats is much smaller. Now this has 49 bin. This is like silicon wafer. It's 3.3 millimeter by 3.1 millimeter. Imagine how small this is. It's like the tip of a pencil pen. It's 49 bin. So if we go down to what we need to look at is the block diagram and the bin layout. So let's scroll down because we need to create this component. So we need to create this 64 pin. Let's scroll down more. Let's do like that until we find, okay. These are the different footprint variations. So what we are looking into, the 48 pin, this guy. So it's a quad footprint QFP. So this is low quad footprint, as you can see in here. So, and quad meaning the bins will be distributed on the 4 sides of the chip. This is the footprint of that. So this is the bins, and this is what I need to see. So if you go down to, there is a table. This is the description of the bin type. You remember when we talk about bin type, electrical type of the bin? It's in here. This is description of these symbols. S means supply bin or power bin. I mean inputs. IO mean input and output. FT, this is a 5-volt tolerant input output. The microcontroller works on 3.3 volt, but this pin can tolerate 5 volt, up to 5 volt as input output. So TTA, meaning this is a 3.3 volt tolerant IO directly connected to the analog digital converter. TC is this standard 3.3 volt. B, dedicated boot 0 pin. This is for the boot up stage. RST, this is a reset pin, and so on. Now you will see a table like that, so don't get confused. Oh, what's going on? Why do I have these pins? Just focus on the bin number according to the footprint you are selecting. This is your footprint, so you need to look under this column for the bin number and see the matching functionality and bin name. So let's start. So bin number 1 is V battery. Okay, so we have, first of all, we have a quad. Let's go to the component wizard. Click on the layout style. So the layout style allows you to choose from a set of predefined symbol patterns where the bin positioning is automatically assigned. So what you need to do is the quad side. This is the case you have in here. When you click on quad side, you will see how the symbol will change in here. So how many bins you have, number of pins? You have 48 pin. You click on 48 pin now. You have created 48 pin. So bin number 1, so the display name for bin number 1, now you need to switch between the datasheet and the symbol wizard. So let's get the datasheet in here. So bin number 1, the name of it is VBAT. So basically you can come in here and switch between here. It's not. Oh, it's not. The problem is this one is like encrypted. Oh, okay. So you need to write it down each one by one. So VBAT, and the designator for this one, it's pin number 1. Don't forget about that. So this is the designator. So 1, 2. Let's put them in order. 4, 5, 6, 7, 8, and they are going in order all the way to 48. What is the electrical type for this pin? VBAT. Now we need to go to the table, or you can change it later, or you can look it in here. So focus on this column, LQFP48, pin number 1, it's VBAT. The bin type, it's power. Remember, S supply mean power. So open this and go into power. Now where is it located when you create a symbol like that. So remember, this is the location on the schematic symbol. It has nothing to do with the footprint. You can put it anywhere in here. It doesn't matter. But if you want to have it like similar to this shape in here on the schematic and footprint, the same thing. So bin number 1 always start from the top left. So you can have it in here as well on the left side. Okay, it will start in here. So let's go back to the table and we need to create the rest similarly. So bin number 2, again, don't confuse, focus in here. Bin number 2, and this is BC13. I don't know if we can, we can copy it from here. Oops. So copy, it's input output. Remember the bin type input output. So bin number 2, display name, it's BC13, and it's input outputs. We can change it in here. Next one, we're still focusing on this. Bin number 3, it's this bin, and it's also input outputs. So bin number 3, paste, and it's input outputs. So we need to do the rest in same way. So one thing we can do, you can download this data sheet. Click on download and download that. And then once you download, you can open the PDF file. Now go to the table. Here you can see that. So we are done with bin number 3. We are at bin number, let's see, we need to do bin number LQFP. And so let's say we need to do bin number 4. Click on the Alt on the keyboard. And now select while you still holding the Alt key down. And okay, now these are not, we don't care about these two in here. So let's take a look at pins. So it's under LQFP 48. LQFP 48. Okay, let's take a look at these. So 14, 15, 16, 17. Click Alt down, select. Now you have selected 4 pins. Copy. Go now to the wizard. Now what are the bin numbers for these? It's 14, 15, 16, 17. So here 14, here 15, 16, 17. These paste, done. So you don't have to do it one by one right now. And what is the function of these? All of them are IOs. So you have to change this into, let me see if we can copy it as well. Paste. Oh, it has to be done one by one. It's okay. Done. So this is how you do it. You can do the rest of the components. So let me do it offline. We don't want to make the video too long because it's straightforward process. So almost done. Alt key 29, 30, 29, and these are, all of them are IOs. Change to IO. Okay, let's go back here. So this chip here we have hold Alt down. So 35 to 38, 35, 38, and this VSS is power, and this VDDIO is power, and this is IO. This is IO. So here, if it's empty, that means it doesn't have IOs. You see IOs in here because this has more bins. So we need this again. So 39. Alt Control C. 39, and these are IOs as well. So we need 42, 42, 43, 44, 45, 46. So IO boot, this is an input, and this is IO. This is an IO. The bootloader is input, as you can see here. These are IO. So 47 and 48 are the last two pins. These are power. These are power in here. Now we can change the side where these exist. Looks like the software automatically distributed these on 4 sides. So you can see on the top, on the left, we have the first 12, because we have 48 pin divided by 4 is 12 pin on each side. So then we have the next 12 on the bottom side. So left, bottom, then right, then top, which makes sense. Now everything looks done except we need to add a description. It's quite maybe important to add a description as a reference. When you hover over the pin, you get a description about this pin. Now the description basically you can put the bin name or something in here. It's not let's skip the description for microcontroller. It's not very important. Maybe let's skip it. Now since this one is done, what you need to do, you can place a new symbol in here. So this is a microcontroller, as you can see. And now after the placement, look at the bin, the length of the bin. We can change that. You can select the bins in here and change this to 200. Let's select everything and accept this one. We need these to be even maybe 300 or 200 is okay. And then we need to move this. I like to have it on the corner like that. So the grid is 100 right now. Okay. And these. For some reason, the editor placed them off the grid. So, okay, can move them to the center like that. And please can move these here. Also, this looks off grid. Change the grid to 10. And okay. Now this is a component. We built the component like that. Of course, you can change how you build the component. Sometimes you might want to have the bins on 2 sides of that component. You can basically move them in here and make sure that your grid is 100 mil. Sorry, this is 100 mil. Now, because you moved the bins when the grid was not set to 100, look what happens now. This is the grid and the bin is off grid, so you need to move it one by one. So what is the other options to do that? Basically, if you select all the bins, go to the edit align to grid. Now look at the component, what will happen. All of them are aligned and to the grid. Now all of them are set to the grid, so it's fine. So you can move them to, let's say this, I need this on this side, so maybe these are here. Move these down. It's up to you to select how they look like. Move it like that. And move everything to the origin point. So this is the component. Now we need to add the parameters. So this is, let's go back and see what component did we select. Here, so this is the manufacturer part number. We go back in here, we need to use it in here. And also for the comment, as we said, we use the manufacturer part number. This is integrated circuit U question mark. This is standard. You can copy the description and start adding the parameters in here. So if you look at the bins, you see all the bins in here. And if you click on edit, you will see the component bin editor, where you can now edit also the name and description and electrical type of this bin, or add a description. This is another way. Now, one point I would mention in here, that the symbol wizard is editable, meaning if you click on the symbol wizard again, you will see the same component you have created with the modification you made on the schematic symbol, and this will allow you to come back in here and do an edit to it. And this is also a very handy feature and very important feature. I like it. It's not like starting a new component. So this is very, very nice feature. So no change to this. So what we need to do now, instead of going and adding these descriptions, link, parameter manually, we can go to the manufacturer part search. We search for the component, and guess what? There is a model for this component, and look how they ST implemented this model. This model implemented by ST. They have it like dual line instead of quad line for some reason. So right click on it, import supplier link and parameter to this component. If we go back to the properties of this component, here are the parameters. They are filled in. We can remove this. We don't need the description. General, you can see the links, and we need to add this nice description, or you can add this detailed description. I prefer detailed description. Done. We have the component right now. Let's add this one to the schematic. Let's place it on the schematic, just to see what's going on. Okay, let's use a bigger schematic sheet. We can go to the tools, click on the tool. Oh, it's in the design template, general template, and let's do A3. Just this document, and okay. So this is a bigger sheet. So let's add the symbol created by the original library from ST. Place. It's loading, and here is the component. So look how they distributed the bins. It's not based on the number of the bins, but it's based on the boards. So bin A0, 1, 2, 3, all the way to bin 15, these belong to one port on the microcontroller, but this is bin 10, 11, 13, all the way to 17, then 29, 30, 31, all the way to 38. Now these bin belong to port B. So it's based on the functionality, it's based on the port. They are distributed in right and left. And now here you can see they are distributed on the power. They are in separate section of the symbol. We have V battery, we have the VDD for the IOs, we have the VDD, we have VDD analog. Then we have the ground, VSS, and then we have the reset pin and bootloader. These are special functionality. And here we have the oscillator bins, and here we have the other oscillator, the 32 kilohertz bins as well. So they are separate because these belong to port C, these belong to port F, and these B and A. So you can do that. and this is a quick placement. Now here it's easier when you connect the power and the ground, and when you port into these pins, and you can divide these pins and place them on the symbol the way you want. Sometimes I customize the distribution of the pins to simplify my schematic design. When I start routing with the peripherals around this component, I can move the pins around. It doesn't matter. It will not change the function of it. So this is how we can create, also how we can use, if we go back to the symbol wizard, it's nice and easy tool to use. Symbol wizard, this is very nice and neat feature to use in Altium Designer. So far we are creating schematic symbol. It's been like 2 hours and 20 minutes, and we are still in the schematic editor. It's very comprehensive review, I know. I'm trying to cover every single aspect in the libraries and component creation with all the features, nice features in Altium Designer. I did not expect it will take that long, but I'm trying to be comprehensive and try to cover everything I can do. So let's keep moving. So let's go back to our slides, because these are my reference to make sure that I'm covering everything for you. So we have covered the symbol wizards. Now, finally, we are at the PCB footprint editor. How we can create a footprint? There are multiple ways to do that. We can manually create a footprint, or we can use the IPC footprint wizard, or we can use the footprint wizard or the batch generator. And there are a lot of things to cover in the footprint. It's even more than what we covered in the schematic. So I prefer to stop at this point and call it a session, and I will record another session, number 8, to cover the footprint, because under the footprint we have manually creating footprint, and then we need to use the IBC compliant footprint wizards. We will talk about it. It's very good tool to use, and also we need to cover that. And then we have the batch generator, then we have the footprint wizard, the standard one in Altium Designer. Then we will talk about the 3D models, how we can create and add 3D models in more extensive way. And then we talk about the land pattern in more depths, and the density levels of the footprints. Talk about these. And then batch shapes, what is required by the standard. SMD lead styles, we'll talk about it. And mechanical layers and component model. We'll talk about this in details. Yeah, we need like 2.5 hours to cover these. Mechanical layer in Altium Designer, screen outline guidelines, and counter yard outline guidelines, and counter yard. So then we have create a component from scratch and the workflow. So yes, definitely I will dedicate like a separate session to talk about the PCB footprint. I will stop at this point, and we'll see you in the next session. Thank you all.